Good. Here's the answer to that question. So Zach's question was, if we're finding the limit as x approaches 0, do I pay attention to this dot here? Is that what you're saying, Zach?
Yeah.
Do I pay attention to this? And a related question that often comes up is, do I pay attention to this open circle right here? I'm trying to get the class to answer this without me just giving it to you.
Isn't the open circle a hole?
Some teachers will call it a hole. On the AP test, they always call it a removable. Well, the open circle doesn't mean hole, to be honest. Like this right here isn't really a hole. I'm not going to say it that way. I know some teachers do, but it's going to cause you to lose points on the AP test if we think of it that way. It's much better to think of this open circle as simply indicating that at that spot, there isn't a dot. That's all it's showing you. Really, what we'd want to show is a bunch of dots like this, and then suddenly not show one. But because there's an infinite number of dots, that's difficult. So they draw a large open circle to simply indicate that at that spot there isn't anything. But yeah, we don't really want to call it a hole. That will lead to some loss of points. Here's my question. I want everyone to answer. Raise your hand, please, if you can tell me what is the precise x and y coordinate of that blue dot. Hands up. Don't overthink it. It's not meant to be a trick. Just want to pay everybody. Trying to get everybody participating again. What is the precise x-y coordinate of the blue dot? Let's go, Trey.
0, 1.5.
Sounds about right. And needs to be replaced. Hands up, who knew that? Quick. Point, 2 for Trey. So back to Zach's question. Because that dot has an x coordinate of exactly 0, when I'm analyzing the limit, it's as if, like, I don't ever look at that dot. Because I have to focus on x coordinates, I have to focus on dots that have x coordinates that are never equal to 0. They have to always be slightly less than 0 or slightly more than 0. Therefore, I must purposely ignore this dot that has an x coordinate of exactly 0. I can't look at that. Did that answer your question? 2 more.
So then what? Sorry.
You're good.
Then what would we do about where there's the knowledge point?
The open circle there.
Yeah, that's
So let's do that one. 2 for Ellie for asking. Hands up. Raise your hand if you can tell me the precise location of that open circle. Hands up. You're good. Good work. Hands up. What's the precise location, Grace?
0, 2.
So that open circle is at 0, 2. How many knew that? Point 2 for Grace. So yeah, Ellie could see, basically answered the question that same thing. This is at x equals 0. I don't think of that when I'm doing the limit. I ignore it completely. Makes sense? Oh, please.
So because the left and right limits are the same, would that mean that the overall limit would be 2 then?
Uh-huh. 2 more. Perfect. No, it's perfect, Ellie. Come on, yeah?
Yeah.
Okay. So we should write that down. The limit, as x approaches 0 in general, that's going to also equal 2. And Ellie gave the precise reason for that right here. When you're answering the orange, don't ever look at the graph. When you answer the orange, you only look at the left and right limits that you've already calculated. Don't look back at the graph. Questions? Please.
If that one also does not exist, because you're talking about the other one as if it went to infinity, it would be does not exist, but in this case it's just 2.
So,
does that qualify as well?
let me say it back. Oh, say it again, August. Sorry.
Like, back on the first question, it said, you said it's either does not exist or whatever, infinity, right?
Let me say it back to you. If we had worked a limit problem and the left limit had turned out to be positive infinity, and the right limit had turned out to also be positive infinity, then we have two ways of expressing the overall limit.
Right.
We could say positive infinity matching these two, or because it's infinite, we could say non-existent.
Right.
Here, we don't have those options. With the left limit equaling 2 and the right limit also equaling 2, the only possible answer here is just 2. Just 2. It has to match. The non-existent part came in because an infinite limit has this debatable idea of, like, do we call it infinite or do we call it non-existent?
Right.
Did that answer your question?
Yeah.
2 more. Anybody else? Sweet. Cool. Back to here. Need a vote. Understanding, feeling good about, hey, look at me, everybody. I promise. If you pay attention to your feelings in this class, you'll be successful. Like, as long as you act on the feeling. Like, if you're feeling good about things, show me that you feel good. If you're like, I just can't quite see it, just raise your hand and tell me I can't quite see it. And then I'll talk with you and try and figure out how to help. But show me how you're feeling. So this is good. This is not so good. There we go, August is
Sorry.
there for a minute. Jared Humphreys, Caleb Hughes. Working on names. There we go. Sorry, I'm checking the whole room. I think we're good. Cool. Awesome. Do you have anything that's bothering you? Please.
So when we're finding the left hand and the right hand limit for those things right there, how do we know that it's like exactly 2 when it's not like 1.99 or something like that?
No, outstanding question. You can see that from this graph that I drew with the computer, that as I make my x-coordinate, as I pick dots whose x-coordinates are closer and closer to 0, as you said, Hannah, the y-coordinate isn't equaling 2, it's getting closer and closer to equaling 2, but it's not ever actually equaling 2. That's what you're referring to, right? So you've got to kind of keep two things separate. If I were making a table like this, I would pick dots whose x-coordinates are closer and closer to 0. So I would eventually be picking something like this. Like that. And the y-coordinate I would observe that goes with this x, you are correct, it would not equal 2. It would be something like this. Does that make sense? This is true, but when you go to state the limit, the value of a limit isn't necessarily what the number actually is. It's what this value here is getting infinitesimally close to equaling. So because this number, as we pick x's that are closer and closer to exactly 0, the corresponding y-coordinate is getting closer and closer to being exactly 2, even though it never is exactly 2. In the limiting sense, we say the limit is 2. Did that help a little? 2 more. Please, Noah.
Is limit kind of just like, call it 2 because once y equals 2, x will equal 0, and that's like,
Oh,
like
3 for that one. Look up. Look. Everybody look. So it's kind of a mistake, so I just want to help you not make it. When you're evaluating a limit, this really doesn't matter. Take 4 right forward. But then I feel better. Put 5. There we go.
I'm gonna keep feeling bad.
Okay. Look. Yeah, you got to be really careful. Whenever you're evaluating a limit, if we're trying to figure out what's happening when x is getting really close to 0, don't ever think about what's happening when x is 0. That's separate. But you have to do what Hannah was doing. You have to say, well, if x gets closer and closer to 0, my y value is getting closer and closer to 2, my limit is 2. If I pay attention to what's happening at x equals 0, that's different. That's this question, f of 0. In fact, hands up, what goes in this blue box? Everybody, hands. What goes in the blue? There we go. Let's go, Cassidy, Paul.
2.
So when x is exactly 0, I can no longer look. Let's go back to here. So when x is, it's like right here, x isn't 0, x still isn't 0, still isn't 0. The only place where we have a dot where x is exactly 0 is right here. That's the only place. And so for evaluating what the y-coordinate is when x is exactly 0, we said 1.5 there, 1.6, whatever. It's just an estimate. But then you have to look at the blue dot. 2 for Cassidy. They want to talk more about that.
So we always have to have a graph to be able to find the limits.
Oh, outstanding. We're trying to find a limit of this function at different x coordinates. So we have to have something that tells us, okay, what are the x and y pairs for this function? A graph is one way of showing you what the x-y pairs are. Equations would be another way. We just haven't practiced that yet. Tables would be a third way. So I've seen AP questions that will use all three. Let's go, Chris. Go ahead.
Would this be continuous then?
So let's look at the definition. 2 more for Chris. The flashcard you made looked like this. It said if the left-hand limit is equal to the right-hand limit, which it is, because the left and right limits were both 2, but it's also supposed to equal the value of the function at x equals 0, which is not true in this case, because the function's value is 1.6. So this function is not continuous at x equals 0. Please, Lincoln.
So you only find limits of piecewise functions?
2 more. Everybody look at me. Look. You can find a limit at any x coordinate on any function. The limit might be non-existent, it might be 5, it might be whatever, but you can find it anywhere. But what you're probably noticing is on the AP test, probably about 95% of the time, they will ask you to evaluate a limit at an x coordinate where there is a discontinuity. A vertical asymptote is one type of discontinuity. This one that we're hitting right here is called a removable discontinuity. This one over here at x equal 2 is called the jump discontinuity. And that's the only 3 types that we study. Please, Mary.
On the flashcards, sorry, this is probably basic, but what does
You're good.
RD stand for?
Say one more time.
The RD.
Oh, gotcha. So RD is my little short abbreviation for removable discontinuity.
Perfect, thank you.
No, thank you for asking. 2 more. Anybody? Okay, cool. Let's copy this over. That's the first one. There we go. Okay, questions? We need to write a conclusion. So here's the conclusion that you should write. Let's get some space. Another way to look at this is an exact dot on the graph. That dot is the blue one. These 2 aren't technically exact dots, but I like to think of them as being dots. It does help the analysis be a little bit easier. So this one here, I like to think of this as being this dot right here. The dot whose x-coordinate is almost 0 but slightly left. And then identify that the y-coordinate of that dot is infinitesimally close to equaling 2. You want me to talk more about that? Okay? This one here, I think of this as being this purple dot right there, whose y-coordinate is infinitesimally close to 2 as well. This one isn't a dot. This is found by comparing the left and the right. This one's back to being a dot. And this one is an exact dot. It's the blue one. So, questions? And visually, a function is continuous at a given point as long as those 3 dots are all infinitesimally close to each other. That's what the definition of continuity is telling you. So this definition is essentially saying if you have those 3 dots and they're all infinitesimally close to each other, then at that x-coordinate the function is continuous. Please, Ellie.
So on the graph when you're trying to find the 2 limits, like the O negative and the O positive, why wouldn't it be getting closer to 1.5? Because there's a dot there? Is it just because you're following the line?
So what you're following is this trend that we kind of outlined in the chart, where we say, hold on a second, the right page. We say we're going to make a list, and we're going to pick x-coordinates that get closer and closer to being 0, but we will never, like one way to think of the word limit is we're going to limit ourselves. We're going to prevent ourselves from ever picking an x-coordinate that is 0. So we pick subsequent x-coordinates, and as we do that, we start to observe a trend. As we pick x-coordinates that are closer and closer to 0, but slightly negative of 0, we see that the corresponding y-coordinate is just getting closer and closer to exactly 2. It really isn't getting close to 1.6. That 1.6 doesn't ever happen until the x-coordinate switches and goes to exactly 0. So the trend is never, like 1.6 isn't involved at all. Because again, 2 more. When I'm doing the limit, I'm closing my eyes to the blue dot. Like when you're finding the limit, your eye should not look at this open circle or the blue dot at all, because they're in a different x-coordinate.
So if that blue dot was like on the pole or on the place,
right here,
it would now become continuous.
That is correct. I don't know for certain, but I think that's where the word comes from. So our conclusion here, 2 more for August. Our conclusion here is this. Write this on your paper. Therefore, and this is a great introduction to the AP test. Nearly every single year they will have one AP question on the written section where you have to do exactly what we're doing. And you have to write exactly what we are writing. If you don't write what is required, they don't give you credit for trying. They give you 0. So, yeah, please.
So those 3 dots, that means therefore.
Thank you. And that's a legal abbreviation on the AP test. Jackson Bergen.
Yeah.
Okay, cool. So I say therefore, let's see, the overall limit as x approaches 0 of f is not equal to f of 0. So f of x has, okay, on the real test you would want to write out the word. On the homework, I'm okay to abbreviate. It's just for you to test yourself anyway. But just keep reminding yourself, on the test I would write it all the way out. It has a removable discontinuity at x equals 0. And now I would get, probably on the written section, 2 points for that. But again, the notation has to be perfect, otherwise they don't give you any points.
Would it be a removable discontinuity or a...
Correct. The way you say it is removable discontinuity. I think I have a card that shows that. 1 second. Hi, Ms. Frederickson, tell me your name again. Hey, sorry, go ahead.
So if the limit was 3, would that be continuous? Or would you write that in the answer?
If the limit were 3 here,
Or if it was x equals 3?
oh, like if we were analyzing what's happening at x equals 3?
Yeah.
Yes, so I have to indicate that all this analysis is all taking place near an x coordinate of 0. Is that what you meant? I didn't answer that very well.
Sort of. Like for this one. If it was x equals 3. Would that be continuous? And would you
Oh,
write
gotcha.
that in too?
That place it will be continuous. That's very good. We'll do that one in a second. Good call. 2 more for Paige. Other comments? Anybody?
So do you have to write that for each question? So like we would have written it for the x equals -1. Or-
Right.
Okay.
So up here, I wrote that it wasn't continuous. Actually, we did write it because I said it wasn't continuous at x equal and that has a vertical asymptote at that point. So. Oh, please.
So what's everything that we like absolutely need to write for our answer?
Say it one more time, too.
What's everything that we need
Gotcha.
to write for our answer?
The key things are you need to show the left-hand limit, the right-hand limit, which then allows you to write the overall limit. You need to write the value of the function at the x coordinate we're analyzing. So those 4 things with the proper notation. And then you need some sort of conclusion to say, what is that all telling you? If that makes sense, kind of. 2 more, please. Go on.
So if the, I don't know, how do you say that again? The f -1 in parentheses equals a.
You say f at -1.
Or yeah, but like what's that called?
Oh, gotcha. That's
value
the
of the function.
value of the function at x equal -1.
Yeah, if that equals the limits, then it's a continual function.
Very good. So let's jump to change boxes here. This is the one that Paige was talking about. Go to the very bottom box, and we'll just kind of go to what Taylor's asking, what Noah's asking. I'll go through again what should be written here. So go to the bottom box. That's x equal 3. Let's go. That one. So we do exactly what we talked about. We write the limit as x approaches 3 now from the left. Whole room, hands up, points for everyone. What would I write after that equal? Hands, everybody. Trying to get everybody's hand to be raised. Take your time. Liza, right?
Yeah.
Go ahead, Liza.
2.99.
So I'm going over here to, so I'm doing this table thing again. I'm picking dots whose x coordinate is slightly less than 3. So that's my x, something like this. And then the limit is asking for me to determine what's the y value for this x.
-1.
Oh, gotcha. It just looks like a negative because there's a little hash mark there.
one,
Everybody
sorry.
does that, don't worry. Does that make sense?
Yeah, it does.
So this is 1. So this limit is 1. Show me your hand if you knew it before we said it. Show me. 2 points, 3 for Liza. I can't remember your last name.
Calhoun.
Sorry. Anybody else? Are they bothered by anything? So back to Taylor, that's the first thing you would write. Now we do the right-hand limit. So you write that down. And you have to write it. If you don't write it, if you just think it, they won't give you points. This is for the written section. Go ahead,
I'm
question?
sorry. Left-hand limits are the negative sign, and then right-hand limits are the positive.
Always.
Okay.
And the reason for that is if you are looking, like I'll turn like how you would be looking. If you're looking at a graph and you're looking at x equal 3, if I go slightly negative of that, I'm on the left side. That's where the name comes from. 2 more. Cool. Hands up. What's the purple hand? There we go. Let's go, Alicia Thomas. Who is willing to support Alicia in her vote for 1? 2, 3 for Alicia. Okay. Please. Caleb.
Since it's on a slope, would it be more, like slightly more than 1?
So that goes back to a question. No, it's a good question.
Just because it's going to the
Right. It's that trend again. You are correct, Caleb, that at an x-coordinate of 3.00001, the y-coordinate is going to be slightly more than 1, for sure. Guaranteed. But for a limit, we're looking for where we're headed. And because we're getting infinitesimally close to 1, we declare the limit to be 1. Cool. 2 more. Awesome. Now we can do the overall limit. Hands up. This isn't a trick. I just want to make sure. Where should you be looking to answer the black? Like, where should your brain be focused when you answer the black question? Let's go, Sarah Ritchie.
At the green and purple.
Perfect. You should be looking left and right. How many were doing that? 2 more. 3 for Sarah. I always slip into the 2 and 3 thing. I'm supposed to stay in the 1 and 2 thing, but you guys just smile and never complain, so whatever. Okay. I'm not sure what I'm talking about. Okay. Questions? Rambling over here talking to myself. Are we good? Sweet. So now you go find the value of the function. Let's go to Brown work. F of 3, hands up. Let's go Acel Mitchell. Who agrees with Acel? Point 2 for Acel. Questions? Awesome. Now you need a concluding statement. So I write, since the limit as x approaches 3 of f is exactly the same as f of 3, f of x is continuous at x equal 3. Please.
How do you know what to explain in the? Are you just explaining the continuity? Is that what
Gotcha.
the therefore is? Or?
I think this will help clarify that. I haven't done a very good job of keeping that clear. That's my bad. 2 for August. Here's really, and this goes back to, I think, Taylor's question as well. The way my brain is working on these problems is it says use limits to analyze. So I always think of these 4 right here. So I'm always thinking of these 4. But then in my brain, I'm going down kind of a ordered list. Here's the first thing my brain is checking right here. This flashcard. I'm looking to see if I have left and right limits that are infinite. And if I have a left or right limit that's infinite, then I know I have a vertical asymptote. And that's the first type of discontinuity that I'm checking to see if I have. It's not very difficult on a graph, you can see it.
Right.
But on a equation problem, like you said to Liza, Calvin, you wouldn't be able to see it, you'd have to mathematically see it. So,
Right.
after I know there's not a vertical asymptote, because the limits weren't infinite, next thing I check is to see if they're equal to each other. That's this flashcard. Because if the left and right limits are different, like this one, then I know I have a jump.
Right.
Discontinuity. Last thing I check is if the left and right are the same. I'm going to check and see, I've got too many flashcards. I'm going to see if the left and right were the same, so this is good, the overall limit. I need to see if that's the same as the value of the function. That's different, then I know I have a removable.
Okay.
And I'm just going to write one of those 4 conclusions.
Oh, just one of them.
Right, so it's either going to be, I find that the limits are infinite, so I know I have a vertical asymptote discontinuity, done.
Right.
If the limits aren't infinite, but they're not the same, then I know I have a jump discontinuity. That's my conclusion.
Okay.
If I find that the left-right limits are the same, but they don't match the value of the function, I know I have a removable. That's my conclusion. If left and right are equal and they equal the value of the function, I know I'm continuous.
Okay.
So it's always one of those four. Did that help a little bit more?
Yeah. And also, is it continuous if you have like two going, like, it's like if it's a vertical asymptote, but they're both infinitely going up, is that continuous?
Oh, gotcha.
Because they're like kind of.
Here's what would happen if we had a vertical asymptote like this, right?
Right.
Like both sides are going up. The left and right limits would both equal positive infinity.
Right.
But because they're infinite limits, it's a vertical asymptote. It's not continuous. Because there is no value of the function in the middle.
Oh, that's right.
To be continuous, the function's value must equal the value of the limit.
Right.
And with the vertical asymptote, there is no function value in the middle, so it can't be continuous.
That makes sense.
Read more for that one. Please,
In our
Taylor.
conclusion, why did we do the triangle thingy?
Oh, you don't have to.
Okay.
The triangle thingy is just it's a weird one, but they let you use it. It's a world accepted symbol for therefore.
Okay.
And as I was writing it, the word therefore just came to my mind.
Okay.
I just used since instead. Does that make sense?
Yeah, so it doesn't matter if you use
Not
it or
really.
not.
No, it's just they want you to write something that's coherent, that uses the right connection. If you say therefore or hence or because, or those are all fine.
Okay.
Does that help? It's good work. Two more for Taylor. Anybody else? Solid. Let's go one more here. Let's go do what's at 2, and then we'll be done with the whole first page. So just same old thing. Oh yeah, please.
Can I just say that last class?
Absolutely.
If it does not have a V8 or jump?
Should I do this, put those down?
Let's pull these out so we can see
All of
them.
them.
Yep. Thank you.
Thank you.
Sorry for going too fast on that. So as I was saying to August, in my brain, I'm thinking of this one first. Like it really does help to go in sequence. Like you have to find the left and right limit on every problem. So I find the left and right limit. If I see that they are infinite, I know I'm done. I'm looking at a vertical asymptote. If my left-right limits are not infinite, but they're also not equal, now I know I have a jump. If my left-right limits are equal, but they don't equal the function's value, that's a removable discontinuity. And finally, if all four are equal to each other, then I know I have a continuous function at that point. Please.
What does it look like when it's a jump?
So on a graph, this is a jump right here. So at x equal 2, this function f has a jump. Because I'll just write it out as we're doing that. If I'm finding the left-hand limit here, we're trying to analyze what's happening near x equal 2. Entire room, hands up. What goes after the equal sign? Hands. What goes after that equal? Let's go Camden and Arlene, right? Go ahead, Camden.
2.
So Camden votes for 2. How many would like to vote with Camden? Point, 2 for Camden. Anybody want to talk about it? Please, Caleb.
I think since because it's x going to 2 on the left-hand side, it's going to 2 instead of that jump, because if we did it on the right-hand side, it would be going to -1.
Just 1, but it looks like a negative because they have that little hash mark there. But you're correct. The limit as x approaches 2 from the right is absolutely equal to 1. Is that what you meant, Caleb?
Yeah.
100% correct. And again, I think it helps to think of it in terms of dots. This brown analysis is me visually looking right here. I'm not looking at the black, I'm looking at the brown. For the green one, I'm not looking at the black either. I'm looking at this green spot right there. Question? Oh, please.
Sorry, why does it equal limit? I was writing things down.
So
For the
if
right
I'm,
limit?
for this one here,
Uh-huh.
so if I'm picking an x coordinate that is not 2, but slightly more, if I go to my graph here, that means here's x equal 2. I've got to pick an x coordinate that's more than 2. You see it? My hand's in the way bad. I can't do it. Still not going to work. Try this way. That's not going to help. I'll go to my desk in a minute. Can you see that?
Yeah.
So as I move this way, what's happening to the x coordinate? And what's the x coordinate getting closer to equaling? 2. I don't go all the way to the red because I can't. So my y coordinate is getting closer to 1. In fact, it's always 1 in this case. I don't know if that helped.
No, I did that one.
Two more, please.
So it's back to one of the flashcards.
You good?
So on the removable discontinuity flashcard, wouldn't it be and if the limit of f of x as x is approaching a doesn't equal f of a? Because if we go back to
Oh, that is
x equals 2.
that is what you call a typographical error. Thank you. Give you a ticket for that one. Thank you. And that just I just mistyped it. Nicely done. Other questions? You finish this off by finding the overall limit. I'll let you finish at home, I think. The overall limit doesn't exist because the left and right are different. Function's value is 2. We have a jump in this case.
So in the, like,
Go on,
in
you're
the
good.
explanation, you would say, therefore, f of x approaching negative or 2 minus does not equal x. We're going to 2 plus. Then there's no.
What you could write at that point is you could just say, therefore, f of x has a jump.
Therefore, f.
Yeah, you literally can copy the flash. That's a really good question, August. You can copy the flashcard.
Okay, and that's it.
That's
what
it.
you're
You're just looking for like which of these 4 situations fits. And we found that this second, the jump situation matches.
Yeah.
So we just use the definition of jump as our answer, basically. Does that help?
Right.
2 more. Oh, everyone, since you're just getting to know me, please don't ever be hesitant. I have a tendency to always say, does that make sense? Did that help? If it didn't, just say it didn't. It won't bother me at all. I say, okay, let's try something else.
So you would say then there's a jump at x equals a.
In this case, x equal 2.
So, okay.
Please, guys.
Is there only a jump if it's a whole number? Like if it's not infinity, right?
This, I'm trying to read your mind a little bit here, Cassidy. Like, to me, visually, that kind of looks like a jump, just like that. Like it's jumping, from here to here. Mathematically, it's not defined as a jump. It's defined as a vertical velocity. Is that kind of what you're saying? Hold up, 2 more. Please, go ahead.
What's the perfect thing you could write down as your therefore statement?
For this one. So I've done this. Pull this over here a little bit. Here's what I would write. I put f of 2. Let's check the room real quick. Hands up. What goes after that equal sign? Quick, everyone. Everyone, what's after that equal? Everybody. Everybody. Let's go Jared Humphreys. No. So who votes with Jared? 2 more, 3 for Jared. So I do all that, Caleb. Then I would write, since the key thing here is these 2 not equaling each other. So I would write the limit as x approaches 2 from the left is not equal to the limit as x approaches 2 from the right of f. Therefore, f of x has a jump discontinuity at x equal 2. That's what I would write. And get 2 points on the AP test for that. Questions? Sweet. Okay, in the packet, which you will do as homework, there are several other examples of how to find limits with graphical functions displayed graphically. Again, there's an answer to every question in the back, so you can do the problem, check, make sure it's making sense to you. We want to move now to equations. So let's go look at number. Skip past those. Let's go to number 5. So looking at number 5. Oh yeah, please.
I just have a real quick question.
Yeah.
When we said like it has a jump discontinuity, does that matter? Can you just say jump?
Oh,
Or
gotcha.
just the difference between those, is there a difference between saying either one?
So, if I were taking the AP test, they always seem to use the word discontinuity, so I would take the extra 2 seconds to write it. It kind of bugs me, like isn't jump good enough? But with the AP test, you don't ever get to talk to the grader. Like you take it and hand it in and you never see it again. So I just try to be a little extra careful, just to be safe.
Wait, what's the other explanation for that jump?
So what he asked was, like in class, I'll just say, hey, it's a jump. Right. But it's technically a jump discontinuity. So it's a little safer to write the word jump discontinuity. 2 more. Okay, here we go. The process is identical. Our thinking is going to be a little bit different, but we start exactly the same way. You write, you gotta go find the left-hand limit. As x gets close to 2 from the left. What's different is we don't have a graph to look at. So instead of analyzing the function f graphically, we have to analyze it with equations. So, go ahead.
Did you choose 2 because the first one, x is less than?
Good question. No, they told me to look at 2. That's a good question. 2 more. Anybody else? Okay. I'm assuming you have had some exposure to piecewise functions in the past, although it may have been a long time, so we'll just do a quick review. This is a formula for calculating y coordinates based on whatever x you want. Hands up. What x am I thinking of right now as I try to figure out what goes in this green box? Hands up. What x am I thinking of as I try to figure out what goes in that green box? Everybody. There we go. Sadie, what is it? 2 points, but no. It's okay. Hands up. Hands up. What am I thinking of to answer this green? I'm not thinking of 2. You cannot think of 2. Oh, no worries. No, take 3 seconds. Now I'm feeling bad again. Take mark down. Oh yeah, 5. No, it says 5. 5 is the going rate for when I feel bad. So, the green box. What x am I thinking of in order to answer that green question? Trey Robinson.
1.9.
There we go. I've got to think of an x that is slightly less than 2. You have to. So I'm thinking 1.999 forever. How many were thinking that? Show me your hands. 0.2 for Trey. You want me to talk more about it? So now I go to my formula. It says, okay, here's how I can calculate the y coordinate when the x is 1.99999 forever. I'm supposed to use this one because the x I'm using is slightly less than 2. And now you just have to be a little bit, I don't know, don't worry about the precision, just get the trend. So we'll go to, Maddox will help me here for a second. So Maddox, if I have 1.99999 forever, that's pretty darn close to 2. It's not exactly, but close enough. So if I add 1 to that, let's see, 2 plus 1 is?
2 plus 1 is 3.
3. So it's really just slightly less than 3 here inside the parentheses. Are you okay with that? So I switch back, okay, 3 squared is?
9.
So I'm just a little bit less than 9. That means my limit's going to be 9. 3 points for Maddox for helping me. Anyone need me to go through that again? Makes sense? Again, don't copy what I do. Make sure you're learning to think how I'm thinking. Okay, cool. Let's do the next one. So then you say, do the right-hand limit. Hands up, please, if you can tell me what's going to be the result of this purple limit. And for hands, what goes in the purple box? There we go. If you're not sure, talk to each other. I got to get everybody to raise their hand. Go ahead and talk if you need to. I'll just wait just a minute. There you go. Right, because limit is all about, in fact, every question we work in this class is about this. It's all about, we have a whole bunch of x, y values. We're trying to analyze them. Well, we're specifically analyzing the x, y value when the x is almost 2. But we don't know what the y is when x is almost 2. We have to use the formula.
Now he's saying, what's his
Every answer to every limit problem we have solved, and that ever solved in this class, is always a right. It's always like they tell you the x. So every limit problem tells us the x. You're good. And then we go figure out the y. Very good. Caleb.
Is it infinitesimally close like that?
So Caleb is voting that the limit will be 10. Raise your hand if you're willing to vote with Caleb. 2 points for Caleb, but we apparently have other answers. So other answers?
I got -2.
So Jackson got -2. So we have 10 as one vote. We have -2 as another vote. Who's willing to vote -2? Well, that's much more popular. I have no idea what the right answer is, but we'll figure it out in a second. 2 for Jackson Bergen, 1 for the rest of you. So let's see. If my x is slightly bigger than 2, I'm going to have Cassidy help me here. No, you're good.
Oh, that was in the bottom.
Yeah, I promise I will help.
Oh, no.
Okay, you're good. So Cassidy, if the x is slightly bigger than 2, and this formula is telling us how to calculate the y value, do we use the first, second, or third line? Now the way you interpret it is you look over here and it tells you which one we're supposed to use. So we're looking to use an x that's slightly bigger than 2. Does that make sense so far?
Yeah.
Okay, good. So this is saying if your x is less than or equal to 2, use this formula. So we don't have that situation. This says if your x is between, like it's bigger than 2, but your x is less than or equal to 4, use the middle formula. The last one says if your x is bigger than 4. So for our situation, which formula fits?
The middle one.
Does that make sense?
Yeah.
I didn't mean to put pressure on you.
Oh, no.
Okay, 3 points for Cassidy. Pretty good? So if we use the middle formula, we go to Hannah. I'm picking a value that's close to 2. Hannah, what's close to 2 squared? Like what's 2 squared?
Okay,
4.
4.
So seems reasonable to me that if it were really, 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 really close to 2 and I square that number, I'm still going to get close to 4. You subtract 6 from that, what are you going to get? Technically close to -2. So our limit really is -2. 2 more for Hannah. Do you want me to talk through that some more? Okay, so I talked to August earlier. I said, look, you're looking for one of 4 things. Do we have a vertical asymptote? Do we have a jump discontinuity? Do we have a removable discontinuity? Or is the function continuous? That's all you're looking for. At this moment, I know exactly what's happening. So hands up. Is it a vertical asymptote, and why or why not? Hands. You don't remember, we got to get some more flashcards in front of you. Here are the definitions. Here's the definitions you're going through mentally. Right? Where's a good one we had there? I thought I had it all laid out somewhere. Apparently not. Here are the definitions you're going through. You're first looking to see this. Are the left and right limits infinite? No, so it's not a vertical asymptote. Then you check this one. Are the left and right limits different? Yes or no? Yeah, so we're done. It's a jump. Please.
How do you know that it's not what is this called?
You're good. Removable discontinuity.
Because it also doesn't equal.
With the removable, the left and right will equal each other.
Oh.
What's different? No, it's okay. You're just misreading the card. What's different is, so look here. It's a really good question, Ellie. With removable, the left and right are equal, which means we have an overall limit. Notice there's no plus or minus here.
Yeah.
The only way to have an overall limit is if the left and right are the same. So I always go in sequence. I first check to see if my left and right are infinite. They were not. I now check to see if my left and right are the same. If they were the same, I would have an overall limit. But again, that's a typo. But then the overall would not match the function's value. So that these two are equal when you have removable. Does that help better?
Yeah.
Well, that was really
The
good
two
grammar.
limits would equal each other, but not the limits.
Not the function's value. Not the function's value. Two more. Anybody else want to talk about anything? Okay, cool. Back to here. Get some more of these flashcards showing up. So we know left and right, so we should write down the overall now. And so the limit as x approaches 2 overall is non-existent. We still need to find the value of the function just for completeness. Hands up. Who knows what comes after that equal sign? Go. Hands. Come on. Think with me. It's all about how you think, not what you do. What comes after that equal sign? Think back to what I did with Cassidy. How I said you use what's here to figure out how to calculate the y values. So we're now dealing with the next value that is exactly 2. So first of all, hands up. Let's go. Shoot, Travis Sessions, yeah?
4.
So Travis says 4. To compute that, Travis, did you use the first, second, or third formula?
I guess.
2 points for guessing. Hands up. Who knows which formula we're supposed to use in y? There we go, Zach.
First one.
We are dealing with the next value. That is exactly 2. So the first formula is the formula we must use because that is the formula used when x is exactly 2 or less. So then we say, let's see, 2 plus 1 is what, Zach?
3 and then you square it.
3 squared is 9. So this should have been 9. Raise your hand, please, if you know it before we set it. 2 points, 3 for Zach. Oh, please, Ellie.
Can you tell me the difference between the definition of the word non-existent and the word undefined?
Outstanding. To me, it's just somebody decided that they should have 2 different words because I'm serious. Like we could spend like an hour and just go back and forth, and I'd be like, I don't know. But what I have noticed as far as a pattern is whenever they're dealing with a function's value, they will use the word undefined. Whenever they're dealing with a limit, they'll either say non-existent or does not exist. But to me, I'm like I'm serious. Like I'll come up with an argument for why one is the other, and then I'll be like, well, that doesn't make any sense. It could just be the other way around. And so anyway, I just think they just chose. Is that not very helpful.
No,
but
that's
yeah.
great, that's great.
3 points on.
Can you just write DID?
For homework, I'm fine, because homework's just for you. It's like you testing yourself, you know what I mean? But on a quiz or an AP test, I'm gonna be very strict. I've never seen them use that abbreviation, so I won't use it. Yeah. There are some abbreviations I've seen them use, so I'm comfortable using them. Otherwise, I just don't want to mislead you into like, dang, you knew it, you missed the point, you know what I mean? Yeah, so. 2 more. Please, go, use.
When do we ever use the last question? Oh, for the next question.
There you go.
X.
Yeah. Just depends on what they ask us. Any other questions here? Well done. Oh, please, Sarah, Richard.
So you don't have to use all of them?
Not necessarily. We're just using whatever we need to answer what they asked us to answer. Please, Cassie.
When they give us that instead of a graph, are all those, is it going to be the same every time, you know? Like, is it going to be x greater than 2?
The pattern will be very similar, not necessarily identical. So these two are identical. They're just 2 different x's. We look through the packet real quick. That's just answers. Hold on. That's graphical answers. So here you see a very similar pattern, but the formulas have changed a little bit. Let me show you another one, Cassie. It's a good question. 2 more points. This one's a bit different, but the same idea. 2 more. Anybody else? In fact, let's go here as long as we're here. So 25. Good of an example as any. So we write the limit as x approaches 3 from the left. Hands up. What comes after the green? Everyone. Want the whole room? Whole room. What comes after the green? Think for a second. It's fine. No hurry. What comes after the green? That's better. Let's go, Josh. Yeah. Now let's go ahead, Josh. 7. So Josh is voting 7. Please raise your hand if you are voting with Josh. Seems very popular. 2 points, 3 for Josh. Which formula did you use, Josh? First, second, or third? First. Our x value is less than 3. So close to 3 squared is going to be close to 9. Close to 9 minus 2, definitely going to be close to 7.
Is it always the first one? Or is it just happen to?
Just happened. And is that common? Yeah. Is it guaranteed? No. Is that going to help? One of the favorite AP tricks is to, I'm serious, like study problems you have done and go, how can we make this one just a little bit different? Yeah. So they'll do that all the time. Well done. Question? Anybody want to talk about? Give me a. Yeah, please. Go.
Well, I'm just talking about the rest of this problem.
Yeah, keep going.
I'm a little ahead, but if x equals 3 with that equation, like for x equals 3 is literally just 2.
It is.
Just
That's another one of those tricks they do. They're like, you're so used to seeing a formula that it kind of messes with your brain a little bit. Everybody look up. Look at me for a second. Stop writing, look at me. Like Noah stumbled across a key idea. I said on the first day of class, I'll keep telling you this. You can't do the problems by remembering other problems. You have to say, what is the rule? What's the concept? Because what's going to happen on AP questions is they're going to do exactly what happened to Noah. They'll do something that's just enough different that your brain will stop. And it'll say, wait a minute, this is different. And then your brain has to go to, what is the rule? The rule is, my x is, so he's one step ahead of me here. He's finding, like, when you go find f of 3, you just have to think, what is the rule? The rule is my x is equal to 3, so I know I have to go here. And then this tells me how to calculate the y. And they're just saying there is no formula for it, it's just the y value is 2. Yep. And that happens all the time on the AP test. You get uncomfortable because it looks different. You rely on the rule. It doesn't really necessarily give you comfort. But you say, this is the rule, it's all I can do, so I follow the rule. If you always follow the rules, you'll be just fine. Ellie, please.
And just to clarify, the difference between the limit as it gets x equals closer just to 3 and have x equaling 3 is just that the limit is like showing how close you can get before it gets to that number.
Very good. I think the table is still the best way to think of it. That if we made a big table for this function, when the x value was exactly 3, we would know the y value is exactly 2. When we're finding the limit, we ignore that. So finding the limit, we ignore that completely. We focus on what's happening here. And what's happening here.
So then, but isn't the overall limit just what does y equal when you're getting closer to 3?
Let me say it in a different way. Everyone, look at me. Look at me. So, no, 2 more. It's really good. Again, it's really common to get those kind of mixed up. When I'm finding this, don't think about limits at all. At all. Just completely separate. It's the y value when the x is 3. When you're finding the left limit, you're looking here. Right limit, you're looking here. For overall limit, don't look at this again. For overall, you're just comparing these two.
Okay.
So the overall really isn't calculated. It's just a comparison.
Okay.
Let's go, let's see it. Jackson, or Jackson.
So then with the conclusion to that, the f of x has a removable discontinuity, or?
Let's keep writing here. 3 more for Jackson. Let's finish this up. What goes in the blue box? Hands. Everybody. What's in the blue for this one? Come on. More hands would be good. More hands. Let's go Parker King.
7.
Choose the first, second, or third formula.
The third one.
X is bigger than 3. We've got to use that bottom formula. So let's see. 2 times close to 3 would be close to 6. So that looks to be 7. How many knew it before we wrote it? 2 more, 3 for Parker. So now back to Ellie's question, Ellie Wagaman. Now the overall limit would be what, Ellie?
7.
And why?
Because the 2 are the same.
Perfect. So we know that the overall limit is 7. Left and right match. We don't. So going down my hierarchical list, I don't have limits at infinity. It's not a vertical asymptote. My left and right limits match. So it's not a jump. But my limit, my overall limit, does not match my function value. Hence, it is a removable discontinuity. And that's what I would write. I'd say since the limit as x approaches 3 of f does not equal f of 3, therefore f of x has on the AP test or on a quiz, you'd want to spell it out.
So we can use the 3 dots on the test.
Oh, sorry to cause any confusion. The 3 dots is always legal. They accept that as an abbreviation on the AP test. What I have not seen them use is the word removal, like the RD quick abbreviation. If you spell wrong, they will not dock you points. Question? Please.
With that, you don't have to explain that the limit of x to 3 minus is equal to the limit
Oh,
of
gotcha.
x to 3. Or do you have to clarify that too?
Yeah, you're like me. I'm always wondering how much do I have to clarify. Based on my experience of reading lots and lots of AP answers, this right here they accept as sufficient. By saying that that has a value, you are saying that the left and right match. Because otherwise you couldn't declare this to have a value. But anytime they ask for an explanation, your brain always does that. You're always kind of like, how detailed am I supposed to be?
Right.
And so that's why I will just practice with you all year and say, if you do this, you'll be fine.
But the general rule is like, you kind of just explain the one part.
Kinda. To be fair, it's a bit of just memorizing what they want.
Sure.
It really is.
Okay.
And I've just done enough that I'm comfortable that this will be sufficient.
Okay.
Well done. 2 more, please. Private.
Is the overall limit always going to either be 7 or it doesn't exist?
The overall limit for any problem will either be exactly what the left and right limits are, or non-existent. Yeah, no other answer. I guess we've said you could put infinity sometimes, but that'd be when the right left match. So 2 more for Russell. There you go. Okay, cool. Your homework is the buff packet. As I mentioned, please don't think of the homework as a task. Think of it as a miniature test. Like, that's the recipe for success in this class. You think of the homework as, hey, I'm going to really think of this as a quiz question or a test question. I'm going to do it as best I can, and then I'm going to look in the back and see if I did what was expected. Okay. Please, David.
So just the rest of the packet.
So the packet is, like, we did a bunch together, whatever remains. I'll expect that when you come back on Wednesday, no, today is Tuesday, sorry, Thursday, you will have that completed. If you need help with the packet, I will be here in the mornings. I'll start coming earlier and earlier as we get further into the year, but for now I'll be here at 7. And then I can stay after school usually until, most days if people are here, I'll just stay until we're done. I don't, sometimes I have a commitment, but often I just stay until we're finished. But anyway, question?
I just want to question on the continuity. Like, how would you phrase it if it was continuous? The limit or like the function is continuous?
What I would do is use this flashcard again.
Yeah, that's what I was.
So I would write right here. I would have my list again, you know, left limit, right limit, overall limit, function value. And then I would say, I'd use this one right here. I'd say since the limit, not left or right, but overall, is equal to the function's value, therefore, the function is continuous at x equals y. So, yeah, go ahead.
I was like, awesome.
The homework after you submitted.
So everyone, hey, just clarification. I don't ever collect homework. The homework is your little self-test, and it's just for you. You should make it as complete and as, like think of it as your notes. You're gonna have to go back and study it for the test, so that's yours. Like, I don't ever collect it. What I do is I post an item on Canvas, and I've already posted one of them that just says, hey, did you finish the homework? And if you're not honest in this class, we'll find out on the test, so I don't really worry about it. So really easy. There's also an item on Canvas already that said, did you come to class on Friday? Or did you weren't in class, did you watch the video, and then you just certify that as well and show it in Skyward. You do. Don't leave until the bell rings, but good job. Yeah, please.
Is there a due date to finish that?
Technically, I want you just not to fall behind in class, but for Canvas, yeah, it's really easy. When you go into Canvas, there'll be like an item that just says, hey, were you in class on Friday? You said yes.
So as far as homework goes, if I'm very confident in my ability to do things, do I need to do all of them? Or could I only do
Gotcha. I'll let you guys that for yourself. And this is be a little bit cautious until the first test, so you get a sense of like how difficult the tests are. But No, you can be smart about it and say, hey, this.
It's still counted.
And you can count yourself. That's okay.
Mr. Smith, can I use this?
Oh yeah, sorry, I was gonna grab that for you, Ellen.
Thanks, Smith.
You're welcome.
Thank you, Mr. Smith.
Let me show you. So where do you want the hole?
Just right here, just a tiny bit. Yeah, you got it.
No, it's not long enough direction. It's really just great. So just find, and then push it all the way back.
Okay.
Get it where you want it centered. And
Okay,
just-
that's perfect.
Oh. Well, it's nice. Oh, that was, there we go. We learned it.
Perfect, sorry.
No, don't worry.
Okay, thank you.
Anytime.
Mr. Smith, I think last time you said that if they were the numbers were the same, then it could be non-existent or it could be 10.
Gotcha.
Like,
Here's what's confusing about that. What it was is if the left and right limits are both positive infinity.
it's a specific one.
Yeah. And I'll
Okay.
look for that.
Okay.
So I'll just say it to make sure we got it. So the left and right limits are both infinite. And you can declare the overall limit to be at one of two things. Either infinite or non-existent.
Okay, Mr. Smith. Okay, and it would be non-existent basically.
That's the idea.
Got it.
It's like,
That makes
like when
more
they say
sense.
limit, we keep saying this idea like I have to do the table, you know, and I'll say, hey, if we follow the table, we see that as, you know, like this thing here, look. Not very graphical like everybody else. Can't talk about a picture. So like here, if I'm trying to find the limit as x gets close to say 2, that would be 1. So I follow this like this. I say, okay, I can see my x getting closer to being 1. And I pay attention to my y value, and it's getting closer and closer to 3. The closer I get to x equaling 1, the closer the y gets to equaling 3. So my limited value is 3. But you're right, infinity just grows forever.
Yeah.
So we kind of think of it as unlimited. Hence, they sometimes will say non-existent.
Okay.
Does that